All right, write down the banner number 2.
There you go. Magnify. Move left to right.
If you need to, blow it up a little bit more so you get used to it. Now, there is and I'm going to pull it up for you, there is an example that I use a good bit with z-scores. When do you use z-scores? When you are comparing apples and oranges. That's when. So I will pull that example up. I think, what edition do y'all have now? Your book.
This is the 12.
Okay, the one I'm pulling out comes out of the green book, the 10th edition. And it's one of the best examples of a z-score problem that I've ever seen. I mean, that I've come across, and that's why I use it. And some people like it, some people don't. I really don't care, but it's a good example. Let's see. This is math what? 120. And today is the what? 11th. And this is 3.4, which is, I'm not going to call it that. I'm going to call it dang old z-score, comma, z-score, quartiles, and boxplots. So I'll go to my handy dandy Google do-jigger, and we'll just type in LBJ versus Shaq. See if I can pull it up that way. Z-score. Let me do Z-score. I think we're talking about a basketball game. LBJ versus Shaq. Z-score. There we go. There is the example that I'd like to use. I want you to write it down. And there's a reason. Thought I could blow it up. There we go. Too much. And you don't have to write it word for word. Just write it to where you know what you're talking about. If that makes sense. Usually I just pull it out of the book. This is the first time I've actually pulled it off of was like somebody's test or worksheet. But that's it. It says with a height of 75 inches, LBJ was the tallest president in past century. With a height of 85 inches, Shaquille O'Neal is the tallest player on the Miami Heat basketball team. And this was done at that time. In other words, it was evidently, this is when when they wrote the 10th edition of the book, that's when he was on the Miami Heat basketball team. Some of you Sports Center 24 hours a day watching people can tell me when that was, but I don't really care. And he says, Lyndon Johnson, among the presidents in the past century, who is relatively taller. Now notice that they have relatively in italics. Any redneck could tell you that Shaq is taller than LBJ, right? But that's not what the question is asking. The question is asking who is relatively taller. Now, what does that mean?
It's like among like their group of people that they're in.
Yes, among their group of people, who is taller? You got to think about that a minute. What's the requirements for being president of the United States?
35 years old.
You got to be at least 35, or you got to be a certain age. I forgot. Is it 35? What else?
U.S. citizen.
Oh, yeah, U.S. citizen. Sorry, had something in the throat. What else? Nothing.
I would say something you should have, but I'm gonna keep my mouth shut on that one.
I'm going to keep my mouth shut too. All right, two. Two requirements. What about how tall you are? So technically, a midget could be president of the United States. Yeah. Somebody in a wheelchair could be president of the United States. Were they?
Yeah.
Yeah. Who?
Yep.
FDR. All right. So let me ask you a question. If a person is tall, if a person that has served as president is tall, then they're pretty much a big fish in a what? Little pond. Why? Because there's no requirement, height requirement, to be president of the United States. So you can have some 3 foot, you can have some 8 foot, 4 foot, you can have some 6 foot, you can have some 6'5". What's the requirement for being in the NBA? Height is not a requirement. It's a what? Advantage. So most people, if you're 6 foot and in the second grade, who's going to be knocking on the classroom door when you get to junior high school?
College
The
schools.
coach, the high school basketball coach. Why?
You're tall.
Because you're tall. All right? So is Shaq a big fish in a little pond or a little fish in a big pond? He's a little fish in a big pond. Now, Shaq is not little by no means. I mean, he's like 8 feet tall, all right, and weighs 300-400 pounds. I don't know how much he weighs, but usually tall people weigh a lot, okay, because they got more, more mass. So, whatever. The whole point is, he's not a little fish, okay, but as the old saying goes, he's a little fish in a big pond. Why? Because people in the NBA are what? Naturally tall, not naturally tall, but taller, because if you are tall, you are pushed into that direction of being a basketball player. See what I'm saying? So you've got 2 ponds. They're asking, which one's the bigger fish in the little pond, is what they're asking. Is Shaq the bigger fish in the little pond, or is LBJ the bigger fish in the little pond? And that's what they're asking. Now, how do you ascertain that? Well, you compare them in one system. You convert each of their statistics into a z-score. The further that z-score is away from 0, the more ER it is. That's one of my little sayings. ER, taller, shorter, smarter, bigger, smaller, whatever the ER is. Most of the time. It depends on how the question is worded. All right? That's why you have to pay attention to the question, because there's sometimes, which is the better test score. And they'll give you a psychology test and a psychology class average and a economics class average. And the one that's closer to 0 is the better score, because it's a score versus a height. I know that sounds crazy, but you just have to, the context of the question, you have to pay attention to. Now, the formula for z-score is right there. If you wasn't able to copy it a while ago, there it is. It doesn't matter. It's the average taken away from the actual value and put over the what? Standard deviation. So you've got to have those 3 things. If you don't have those 3 things, you can't convert it to a z-score. So how many numbers are they going to give us in this problem? 6. 3 for Lyndon Johnson and 3 for what? Shaq. So let's look forward. Now, I'm going to go out on a limb here and assume that some people know how to read. And the reason I say that so loosely, okay, bring it down, Vanna. hit minus until you see my menu, hit minus. Just keep hitting minus until you see, there we go, I think that's it. When you read the question, it's going to say the standard deviation is, and it's going to say the mean is. When it gives you that, you're supposed to plug and chug into, where it needs to go. You don't sit there and go, okay, the mean is 75, or let's see, the mean for, let's see, what is it? I'm looking for the mean of the presidents. Okay, presidents, mean of 71.5, and sit there and go, I don't know where to plug it in. Okay, you need to read the formula. Just like I told you in the last class, you need to read the formula, and if you have a question, go back to the formula, because the formula will give you the, and it's not gonna, okay, so the board's not gonna work today. That's because somebody unplugged it. Must be the sound Nazis. There we go, it's out of orientation. But anyway. X minus X bar over standard deviation. So Z is equal to X minus X bar over standard deviation. So we got to find the Z-score for Shaq and the Z-score for LBJ. So the Z-score for LBJ is going to be his height, which is 75, minus the what? The president's what? Mean, which is 71.5. Over the president's standard deviation. All right, somebody crank that out. Take your calculator and crank that out. I'm sorry. 1.67. 1.67. Thank you. Right here. 1.67. At least you know I'm not copying the notes. Now let's do the Z-score for Shaq. He's 100 inches tall, 85 minus 80 over 3.3. And somebody give me that number. 1.52. So who's the big fish in the little pond? LBJ, because he's further away from zero. Okay? So who is relatively taller in their own population? The president is taller. And why is that, do you think? Because there's no what? Height requirement for being president. That's why. I mean, whoever the tallest president is, I don't know. I'll have to look because we've had several since LBJ. I don't know. Somebody have to Google it and let me know who the tallest president is now. We know who the biggest president is. Who's the biggest president? Taft. He was like 500 pounds. I think he was 315, wasn't he? Somebody look up the tallest president. You'd be surprised, but W was very tall. Couldn't tell it on TV, but he was pretty tall. I don't know who the tallest is. Somebody good one?
It says the two tallest were Abe Lincoln and LBJ, both at 6'4", and the shortest was James Madison at 5'4".
What was W? I just remember him talking about W on TV one day saying he was pretty tall. That's why.
6 feet even.
No, he's not tall.
That's about average for a guy.
No, but some people, I guess, some journalists that were covering him, I guess, thought he was tall. Maybe they was short. I'm sorry, vertically challenged. All right, so that's why you use Z-scores. Z-scores. You can compare apples to oranges now. Now let's talk about quartiles. Well, that's what you're going to be tested on. I mean, you're going to be tested on Z-scores. You're going to have 2 or 3 questions on the test about Z-scores. But, you know, I'm not going to sit here and tell you this is difficult. It's really not that difficult. No sneezing in class. All right. Let's go to the next page. There we go. Percentiles. I want y'all to go back to the empirical rule. Go back and look at the empirical rule. What's the page is that on? 103? All right. What is a percentile? Well, I'm going to go and get on the handy-dandy board up here, and I'm going to show you what percentiles are in respect to the empirical rule. Okay. I think we can pretty much say that this is the screwed up room. This is the only room where I have trouble with the technology. And we all know it's a conspiracy and whose fault it is. All right, the empirical rule basically says this. You got to help me with this one because I forget this one. What's this one right here? 103. Just round. I don't need the decimal. Just no. Turn back, Mr. Caldwell. You had it right there, right beside 34. What is it?
17.59.
17.5. Good enough. Or 18, whatever you want to put. Which way do we read? We read left to right, don't we? Unless you're from the Middle East, Masalama. So we read left to right. So, remember your gas tank? You know, gas tank in your car? Dang old. Let's see. I think it looks something like that. Everybody with me? Dang old. Look familiar? Except for that slanted line on the bottom, it should look like that. Alright, so where am I at here? Empty, Hubert. Yeah, that's, correlation right here. Y'all can speak, can't you? Empty. And then right here, we're about a what? Quarter tank. What about here? About a half tank. And full over here. All right. So your percentiles comes basically from the empirical rule and where you are in relation to center. Of course, center is the most important thing in statistics. So we could say this is the 50th what? Percentile I'm sorry about the orientation. I can't calibrate it because for some reason it doesn't want to calibrate today. So you're just going to have to try to do the best I can without having to start it over. Now, you can also call the 50th percentile the what? Well, which quartile is it? If this is the first quartile, what's this? The second quartile. Okay, you need to get used to. Now, it's not exactly the 50th percentile, but I'm trying to get you to relate how to read the percentiles. I don't want you reading 28th percentile and coming from the right this way, because we don't read from right to left. All right? So this is the 25th what? Percentile. And the what? First quartile. Good. Of course, this is your, down here is your mean. And this is your 75th percentile. And your third, what? And then your max is over here. Your minimum number and your maximum number. All right, now, when we talk about percentiles and quartiles now, you know what it's in relation to. It's in relation to these three guys right here. Now, I want to say it again loosely. I'm not saying that these three marks right here are exactly at the 25th, 50th, and 75th percentile. They're not. This one is the only one that's at the mark. But what I'm saying is, when you say the 23rd percentile, I want you to say to yourself, well, the 23rd percentile would be probably right in here somewhere. That's what I want you to be able to do. Okay? Because when we get to z-scores in chapter 6, you're going to be able, I want you to be able to plot the line where you think it is. And in order to do that, you've got to know where the percentiles are. Okay? Now, the formula for percentiles of a value is right here. Finding the percentile of a value. In other words, you're given a bunch of numbers. Blow it up a little bit, Dana, please. You're given a bunch. That's good right there. Break it down a little bit, or minus it. There you go. All right. You're given a bunch of numbers, and they ask you, what is 24? 24 is the what percentile? Or they ask you what, in this case, they say 23. What is 23? And they ask you what percentile that is. Well, you got to count. Count where the first 23 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? 11. So how many values are less than 23? 10. So 10 goes right here. Go back down, or minus it all the way down, please. Thank you. So that number is 10. Divided by, how many values are there? 40. Multiplied by 100. Please do not use a calculator for this, because when you're hanging a sign around your neck that says, I don't know how to do math. Why? Because what's 100 divided by 4? So what is that? What is the 23? It's at the what? 25th percentile. Okay? Because what happens to the zeros? They cancel. And this is 100 over 1. 100 times 1 is 100. Over 4 is equal to 25. So 23 is at the 25th percentile. Now, Hubert, there's 2 or 3 23s. You don't worry about it. You come to the first what? The first 23, and then you count the number before. Now, there is a test question. I usually give you all a test question on that just so you'll know how to find the percentile of a number. And that's how you do it. Not rocket science. What I really want to get to is the box plot, because the box plot is what a lot of people get kind of confused on. Okay? All right. The other thing that you're going to be asked about is simple and not very difficult, is finding the percentile. Will you please stop? All right. Sort the data. First thing you do is sort the data. And then write down this formula. Blow it up, Dana, please, if you need to. L is equal to Kn over 100. I write Kn over 100. L is equal to Kn over 100. Well, Hubert, I thought you just gave us a formula. Yeah. That's when you're given a bunch of numbers. You're given a number, and you're asked what percentile it is. What's this one? This one tells you which number is the 50th percentile, or which number is the 30th percentile, or which one is the 33rd percentile, and you got to go in and find the number. So the first one, they give you a number, and you find the what? Percentile. Here they give you a percentile, and you find the what? The number. So you might want to write that down. In the first formula, they give you the number, and you find the percentile. Give the number, find the percentile. In this formula, you're given the what? Percentile, and you find the what? The number. Okay, demagnify it, please. Excuse me. And they give us a, well, they must be on the bottom of the previous page. Okay, they give us a table, and they say that they want to know the 18th percentile of the previous. The 18th percentile. Where is the 18th percentile? I don't know what that is. Go away. All right. The 18th percentile. Where is the 18th percentile? In other words, where is the 18th percentile? It's right before the 20th percentile. Where is it? Well, 18 is going to be your K. So you would take your 18. Somehow I've turned this thing. There we go. Hard to do when this thing is not right. You're going to take the 18 and multiply it by n. Now, what have I always told you n is? What is n? How many numbers are in the group, right? So in this case, n is what? 40. And divide by 100. Do you need a calculator? Not necessarily. Because what happens to these two zeros right here? And that leaves you with 4 over 10. And what can I do with that 4 over 10? That could be what? 2 over what? 5. And now you got 18 times 2 is what? 36. Right? 36 divided by 5. Or you can say 72 divided by 10 is 7.2. It's a miracle. What's the answer? Huh? 7.2. You do not need a calculator for that problem. If you have to use a calculator for that problem, you need to work on it. Don't raise your hand and say, I'm talking about you. I hadn't looked and seen if anybody uses a calculator. You do not need a calculator for this. 7.2. Well, what does the flow chart say about decimals? Dango, let's go read it. It says if you get a decimal, I don't care what kind of decimal it is. Today is work with a screwed up computer day. Did y'all know that? You know, most teachers would give up and just cut class short and make y'all leave. But I'm determined. I'm not going to do that to y'all. You know why? Because somebody will complain to my boss that I let y'all go early. That's why. You don't believe me? I'll bet you a biscuit on it. What happens if L is a whole number? Then you count to that number. What happens if L is not a whole number? Write that down. You round up to the what? Next number, and you count to that number. I don't care if it's 7.01. Does it say anything about 7.5 or 0.5? It says if it's not a whole number. What's not a whole number? 7.01, 7.99, 7.5, 7.3. It doesn't matter. If you do the calculation and you come up with a decimal, I don't care what the decimal is, then you have to bump it up to not 7 but 8, and you count to that number. So let's go back to the table. Dana, go down. Thank you. Go back to the table. Kind of help if they put the table on the same. And count how many spaces? 1, 2, 3, 4, 5, 6, 7, 8. So 22 is your 18th percentile. Or whatever one we were looking for. And that's how you do the percentile to the number. Again, is it important? Well, you might have one question on the test about the percentiles versus 4 or 5 about the box plot. So let's get to the box plot.